Hey guys, Mr. T here. This is another video on graphing functions and transformations of them. So last time we talked about translating functions, now we're talking about stretching graphs of functions, and that occurs by multiplying the value of the function or the variable of the function by a constant k. So if the value of the function is multiplied by k, this is what you'll find, it's f of x times by k. Or if the variable of the function is multiplied by k, it's the function of k times by x. These both result in stretching of the original graph y is equal to f of x. The first one is vertically, and the second is horizontally stretching. So let's have a look at vertical stretching of a graph. If the value of a function is multiplied by a constant k, so as I said before, it's k times by f of x, this results in a vertical stretching of the graph of y is equal to f of x by a factor of k. So if k is greater than 1, the points on the graph of y is equal to f of x all move away from the x-axis. That's why it's a vertical stretching. It moves up and down because it's moving away from the x-axis, which is horizontal, and they move away by a factor of k. So if k is greater than 1, the points on the graph, the original graph y is equal to f of x, are all going to move k times further away. If k is between 0 and 1, it's never going to be negative in this case. Negative of a function comes in later in the last transformation. If k is between 0 and 1, the points on the graph of y is equal to f of x all move closer or towards the x-axis by a factor of k. E.g., they move k times closer to the x-axis. So that's a vertical stretching, well, a squeezing towards the x-axis. So let's run an example of this, because that's a bunch of words again that may be difficult to understand until you see it in action. So let's use the same example we've been using before. Our function of x is going to be x squared. And then we're going to graph it, so make that function equal y, so the y value is always going to be whatever the x value is squared, and that's graphed in blue below. We've seen that before, we're going to see it again. To use an example for this. So what would y is equal to 5 times by the function of x look like? So we have said that's going to result in the points all moving away from the x-axis by a factor of k. So it should be stretching upwards. To mathematically be accurate about that, we need to decide on some points for this. So if x was 1, I'm going to substitute a whole bunch of values of x's into here so I can draw the graph. So the first one, y if x is equal to 1, is going to be 5 times by whatever 1 squared is. So it's going to be 5. Y when x is equal to 2 is going to be 5 times whatever 2 squared is, which is going to be 20. Y when x is 3 is going to be 5 times whatever 3 squared is, which is 9. 9 times 5, 45. So, actually I'm going to draw that in red. You'll see that this graph is stretched upwards. It's still going to start at 0, but when x is 1, it's actually going to be at 5. When x is 2, it's going to be at 20. 5, 10, it's not even on this grid, but it'll be somewhere up there. So the resulting graph is going to look something like this. And does that agree with our rule above, that if k is greater than 1, the points on the graph all are going to move away from the x-axis by a factor of k? Well, k in this case was 5, and at this point, on the original graph, the graph was 1 unit away from the x-axis. Now that we've multiplied it by k, it's 5 units away from the x-axis, which is 5 times what it originally was. So yes, it's a factor of 5 away from the x-axis. It's been stretched up. So now let's look at the opposite case, when k is between 0 and 1, and I'm going to get some points again. Y when x is 1 is going to be half of 1 squared, which is 0.5. Y when x is equal to 2 is going to be half of 2 squared, which is 4/2. Y when x is equal to 3 is going to be half of 3 squared, which is 9, which is going to be 4.5. So this graph, if k is 0.5, it's between 0 and 1, it should be causing a vertical stretch where the points all move towards the x-axis by a factor of k. They're going to be k times closer, and I think that's what we're going to see here. When x is equal to 1, y is going to be half, 0.5. When x is equal to 2, y is going to be 2. When x is equal to 3, y is going to be 4.5. Let's do another one. When x is equal to 4, y is going to be half of 4 squared, 16, 8. 5, 6, 7, 8. Alright, so we've got our dots there to help me draw it. So as you can see, it's been stretched. Well, it's been squeezed down a bit. The points are all closer to the x-axis by the factor of a half. So this in green is y is equal to 0.5 times by f of x, whereas the one in red is y is equal to 5 lots of f of x. Okay, so that's an example of vertical stretching. Now we have to look at horizontal stretching. If the variable input of a function is multiplied by a constant k, so for example y is equal to the function of kx, the constant is timesing by the variable, it's not timesing the whole thing this time. This results in a horizontal stretching in the graph of y is equal to f of x by a factor of 1 over k, so the inverse of k. So if k is greater than 1, the points move towards the x-axis, so it's like a vertical squeezing up, moving away from the x-axis. The points all move towards the y-axis by a factor of 1 on k. If k is between 0 and 1, the points all move away from the y-axis by a factor of 1 on k. So once again, we use the example of x squared. The graph of y is equal to f of x this time, and our f of x is x squared is in blue below. I've already drawn that. What would y is equal to f of 2 lots of x look like? So I'm going to do points again. I'm going to do that in red. What's y going to be when x is 1? This time you're multiplying the variable before applying the function. So when y is equal to 1, the variable when x is equal to 1, the variable is 1. It's being timesed by 2 first before I apply the function, which is squaring. So 1 times by 2 is 2, squared is going to be 4. When x is equal to 2, it's going to be multiplied by 2 first. It's going to be 4, squared, it's going to be 16. Y is when x is equal to 3, 3 is going to be times by 2, 6 squared. You apply the function, it's going to be 36. So here you're going to see that when the constant is greater than 1 and it's multiplying the variable, you're getting a horizontal stretch towards the y-axis when I draw that in here, because at x is equal to 1, it starts at 0 still, but at x is equal to 1, y is going to be 4. When x is equal to 2, y is going to be 4, 8. It's going to be 16. It's off the grid. It's going to be up there somewhere. Right there. Alright, so tricky to draw. when it's not even on the grid, but we'll manage. So you can see that it has stretched it horizontally towards the y-axis by a factor of 1 on k. Well, k was 2, so 1 on k is a half. Are the points all half the distance away from the y-axis they were before? Well, here, when x is equal to 1, y is equal to 4, that is 1 away, whereas before it was 2 away, so it's half the distance away from the y-axis that it was before, so that confirms the horizontal stretching for a positive k. So that is y is equal to f of 2x in red. Now in green, we're going to do the opposite way. I need some points. So this time, you're halving the variable before applying the function, which is to square. So 1 halved is a half, and a half squared, a half times by half is a quarter, y of 2. So when x is equal to 2, halve it first, which is 1, and then you apply the function squared. 1 squared is 1. When y is equal to 3, halve it, 1.5. Oh, what's 1.5 squared? What's 1.5 times by 1.5? Not something I can do in my head. 1.5 squared is going to be 2.25. When x is equal to 4, halve that, 2 squared is going to be 4. Okay, so you should be able to see that when k is between 0 and 1, it's multiplying the variable in a function, the points all move away by a factor of 1 over k. So at x is equal to 1, y is going to be a quarter. At x is equal to 2, y is going to be 1. As x is equal to 3, y is going to be 2 and a quarter. When x is equal to 4, y is going to be 4. Let's do another one. 5. Half 5, 2.5. 2.5 times 2.5. 6 and a quarter. So at 5 it's going to be there. So I've got some points now that I can use to draw my graph. So you can see that when the constant is between 0 and 1, and it's multiplying the variable, it's actually caused a horizontal stretch out away from the y-axis by a factor of 1 on k. Is that correct? Well, 1 divided by k, which is a half here, is 2. So at x is equal to 2, all of these points are twice as far away from the y-axis as they were in the original blue graph. Alright, so that's just confirming the rule that's given here, that if k is between 0 and 1, the points all move away from the y-axis by a factor of 1 on k. So that is vertical and horizontal stretching of a graph of a function. Hopefully that helps you out, and I'll see you on the next video.